Hi, and welcome to this lesson. In this lesson, we will look at the different stages in writing a program. As a part of our earlier lessons, we had an introduction to the basic elements as in the Java programming language. And in this lesson, we will look at the different stages in developing a program. Alongside, we will use an example of creating an application that works as a calculator. Finally, we will discuss the indicators of a good program. Let us get started. The programming process. Programming is the process of specifying a set of instructions that solve a problem or help achieve a certain objective. Programs can be applications for image editing, managing student information in a school, and so on. The task of a programmer is to write a set of instructions that help achieve the objective. The tasks involve the following stages. Identifying the problem. This is the first stage and involves an understanding of what to build. This is followed by designing a solution wherein an approach to achieve the objective is designed. This is followed by writing the code wherein the design is converted into an implementation and written as a code. The solution is verified to see if it meets the desired objective. If it does not, debugging is performed to locate the error and correct it. Alongside, documentation also happens. We will look at each of the stages in further detail now. The first stage is identifying or defining the problem. The first stage in programming is to understand the objective that is to be achieved and the product that is to be built. Let us take an example of creating a calculator application. Typical tasks at this stage would involve identifying the users of the application, namely if the application is being used for calculating monthly expenditure in a household, or if the application is to be used in scientific calculations or research. Thus, based on the end user of the application design might change. Identifying all possible operations that the calculator is expected to perform, namely arithmetic, logarithmic, etc. Identifying the precision required. Precision refers to the number of decimal points, that is the fractional component. Identifying the range of inputs that the application is expected to handle. Here, we are developing a calculator application. We should try to understand from the end users if the calculator is supposed to handle negative numbers, etc. This stage is crucial as the decisions that are taken at this stage serve as the foundation for the final program. Thus, the end result of this stage is an understanding of what to build. Let us proceed to the next stage. The next stage involves designing a solution. As part of our earlier stage, we had an understanding of what to build. This stage involves deciding how to do it. This involves deciding on the programming language and defining the steps and the overall approach that is required to achieve the objective. Pictorial representations of the steps of the approach using flowcharts are used in some cases. Let us have a look at a flowchart. For designing a calculator, the first step is to read the inputs, namely the operands on which the operation is to be performed. This is followed by a listing of the possible operations. The choice of the user is obtained. Based on the user's choice, one of the many actions is performed, namely addition, subtraction, multiplication, division, or a modulo. Finally, the result of the operation is displayed to the user. Let us take a comparison. In building a room, first, prior to building the room, a blueprint is constructed. A blueprint has all of the details and the measurements that are required for building the room. Similarly, at the design stage, all of such important approaches and the steps are listed down so that can be referred to at a later stage. Let us proceed to the next stage, which is coding. This is the stage of writing the code in the chosen programming language. The decisions that were taken in the earlier stage, namely stage 2 or the design stage, are referred to while coding the solution. While building a house, the builder refers to the plan or blueprint that was created in the design stage. Similarly, while coding, the person who writes the code refers to the design that was created earlier. The next stage in the process involves testing and debugging. This is the stage of verifying if the code performs as expected. A sample of the inputs is given to the program to ensure that the expected output is obtained. If any errors are identified or if the program does not behave as expected, debugging is done. A bug is a term that is used to refer to any mistake or an error in any part of the program that causes it to behave unexpectedly. Debugging is the task of locating the error and correcting it so that the code performs as expected. This cycle of coding, checking, debugging, and checking again continues until the program is error-free and it behaves as expected. Now, let us move to the stage of documenting the program. This stage does not necessarily occur at the end of all of the programming stages, but it happens alongside each of the stage. Let us take an example of a real-world scenario. When building an industrial strength application, there are tens of thousands of lines of code that is developed by a large team of developers. The developers, namely the designers and the programmers, understand the structure and behavior of the application. In a real-world scenario, a single programmer is not associated with a program for its entire duration and moves across jobs. The understanding of the structure and the behavior of the application could therefore be lost. So, to avoid this, documentation is performed. Thus, documentation helps with the onboarding of new team members so that they can understand the structure and the functioning of the program. And it also helps identify where changes are to be made when fixing bugs or adding new features. Thus, documentation is the task of writing down important information and the description of the program that will serve as notes. This happens at each stage. Now that we are done with different stages that are involved in a programming process, let us have a look at a few indicators of a good program. This is not a comprehensive list or a guideline, but a few indicators that we could practice while writing programs. The first is naming variables and methods meaningfully. Instead of using a variable name as X or Y, it is better if we name variables that suggest their usage, like student age, for example. Using comments wherever necessary to make the program more readable and understandable. Moving repeatedly used code into a separate method so that it can be called whenever needed instead of just repeating the same lines of code at multiple places. Performing a comprehensive and a complete testing that checks the code for different inputs. Testing the program thoroughly is a good practice to ensure that the code behaves as expected. Removing the code that is not needed so that the program does not look bulky and has only the necessary lines of code. We have reached the end of this lesson. Thank you.